All right, one more quick beat frequency example. This one is going to exploit the different speed of sound as a result of different temperatures to create slightly different frequencies, and those two frequencies will result in a slightly different, or those two frequencies will result in a beat frequency. Two instruments that are perfectly in tune are used to do an experiment. They both play a pitch of 512 hertz. However, one instrument is taken outside and played lowering the frequency. The temperature inside is 21 degrees, the temperature outside is 5 degrees. Determine the beat frequency. So, the first thing we're going to do is we're going to calculate the speed of sound at 21 degrees Celsius and at 5 degrees Celsius. At 21 degrees Celsius, 332 meters per second plus 0.6 times my 21 works out to 12.6, 344.6 meters per second. At 5 degrees Celsius, I'm going to get 335 degrees, or 335 meters per second. Now it's designed to play a pitch of 512 hertz at the 21 degrees. So the pitch is going to change due to the change in temperature, but the wavelength of the instrument is set by the geometry of the instrument, the physical size of it. And so regardless of whether it's played at the 21 degrees or the 5 degrees, the wavelength is going to remain the same. The instrument isn't going to grow or shrink in the temperature. So what I'm going to do is I'm going to use this 512 hertz at 21 degrees to predict the wavelength that's being played by the instrument. Then I'm going to take that wavelength to 5 degrees, find the new frequency, and then I'll be able to compare the two. Using the universal wave equation, and then if I assume that wavelength remains the same, then I'll be able to find the new frequency here. While I'm calculating this, I'll just say one more time that wavelength would stay the same because it's based on the physical shape of the instrument, which isn't going to change in the two temperatures. So inside it played 512 hertz, outside it's playing 498 hertz. The beat frequency, or difference between those two things, would be quite large at 14 hertz. So changing the temperature, since the wavelength depends on the shape of the instrument, does not change the wavelength, but it does then change the frequency since the speed has to change. Those two frequencies being different will produce a beat frequency of 14 hertz.